Hello, Course 3, and welcome to the Kaloran Show. Today we are talking about Lesson 90 and sets. This can be a very intense lesson, and it's a lot of new material, so make sure you got your writing utensil out and you are ready to go. The first thing I want to talk about with sets is that a set is actually defined as a collection of elements. Okay, so this is a very important vocabulary term for this lesson. So make sure that you define what a set is. Most important things about sets or different parts of sets that we need to have included in here. It can be almost anything from shapes to numbers to groupings of people. Could be almost anything in your set. Anything could be your elements. The other thing we're going to include with sets is that there are braces. Braces are what group your element. Oof, that's a terrible brace, Mrs. Corn. Okay, braces are what are going to kind of group your elements. So they're going to look like this, and they're going to make a grouping of your set of numbers or shapes. The last thing that we are going to introduce in this first page is your elements. So those would be the objects that are located. So maybe we have a set of whole numbers. So your objects, your elements would look like this. Okay? This last thing I'm going to include is if these are our elements, and we are talking about our set of whole numbers, those are going to continue on in that pattern. Okay, so those last three dots that I included there, those are called ellipses. Okay, just some vocabulary before we even get started on today's lesson. So we're going to be denoting sets and writing our own sets and creating different types of sets. So let's continue on. Here it says use set notation to denote the set of even integers. Okay, now keep in mind we've talked about our rational numbers, okay, our integers, our whole numbers, our counting numbers, or our natural numbers. So when we're talking about even integers, recall that if we want a set of even integers, we have to start with our open brace. Even integers, remember integers are your whole numbers and their opposites. So we're going to start with a few ellipses because they are obviously going to continue on in that pattern going that direction. We'll also have 0 and 2 and 4, and guess what? It doesn't ever end. So we don't want to sit here and write all of the even integers, but we want to have set notation to describe what we're talking about. So there would be a set notation to denote the set of even integers. Moving on to the next page. And here, use a set notation to indicate whether each number is an element of the set of rational numbers. So we talked about rational numbers. Rational numbers are numbers that are a ratio of two integers. When we talk about elements, we are going to use a symbol that looks like this. So this means 2 is an element. So make sure you write what that symbol means, okay? And 2 is an element of the set of rational numbers. Okay, so 2 is a set of rational numbers. That is what it would look like. We'll go to 1/2. 1/2 is also a ratio of two integers. So 1/2 is also a set of, okay, another form you might see for rational numbers is going to look like this. Okay, that's a symbol for rational numbers. So if we don't want to write out the whole rational numbers, it kind of looks like a funky Q. The last one is a square root of 2. Now the square root of 2 has no terminating decimal, which means it was not a ratio of two integers. So instead of it being an element of the set of rational numbers, it is not an element. Okay, so not an element, you just put a cross right through that different looking E. Okay, so there is writing in set notation and determining if they are elements, showing me that they are elements. In the next one, we're supposed to graph the elements of each set on a number line. Okay, so in A, they want us to graph the set of integers. Okay, this is something you guys have been having trouble with so far, so please pay attention. Okay, obviously this line is never going to end, but we need to demonstrate some sort of data that's going to show us what this is going to look like. So if we have all of these numbers graphed, we need to put a point on these integers. Remember, integers are not decimal numbers, okay? They are their whole numbers and their opposites. So we only put dots on the set of integers. So this would be a picture for your set of integers. I'm just going to use the same graph and change colors. So for B, I'm going to use green on the same number line. They want the square root of 1. So the square root of 1 is equal to 1. So we'll put that right there. I also know the square root of 4, which is not 4. The square root of 4 is 2. So I'm going to set my square root of 4 at 2, because they are exactly the same thing. Now we have these two middle ones that we don't know, but we could average or give an estimate. So the square root of 2 is going to be almost 1.5, so we're going to put the square root of 2 right there, and the square root of 3 is just a little bit larger, almost equal to 2, but not quite there. So there we have graph the set of integers as well as the square root of 1, square root of 2, square root of 3, and square root of 4. So keep on graphing them. All right, in our next one, we're going to talk about more symbols that you need to know to work with sets of numbers. So the first thing I'd like to talk about is your rational number set. So before I gave you a rational number symbol that looked like this. Okay, this means rational number. So when you have this symbol in your book, this is what all of these symbols are going to mean. We also have our real numbers. Okay, write these down because you need to understand them and you need to know what they mean. If you just write a symbol and you don't know what we're talking about, it's going to be hard to understand what they mean. This is a natural number. Keep in mind those are also called your counting numbers. Okay, and then we have our integers. Okay, so when you see these in your book, that is what they are going to look like. They describe our different types of numbers. Another picture we're going to be looking at today, which describes sets of numbers, is a Venn diagram. Okay, I know you've seen these before. Venn diagrams show relationships between different types of elements. Okay, so we're going to be looking at Venn diagram, and where the Venn diagram is going to bring us is it's going to be talking about our different elements of sets of numbers, okay, and not elements. Remember, we have elements and not elements. We also are going to be showing different types of information that comes out of the Venn diagram. So if we have a Venn diagram that looks like this one right here, this is called the intersection. Okay, so when we look at intersection, we are going to be looking at a form of an upside down U. This means intersection. And it means it is a solution of both sets, okay? So if we were talking about a rectangle and a rhombus, what would our intersection be? Our intersection would be squares, because squares are considered to be both rectangles and a rhombus. Okay, we also have different types of uses for these Venn diagrams. If we're talking about everything in the Venn diagram, all of it included together, we're going to call that a union. Okay, the inclusion of all elements. of sets. So those would be called a union there. If none of our Venn diagrams have anything in common, these are called an empty set. Okay, so we call that an empty set. And the last one, if all of one part of our information, so like our whole numbers, all of our whole numbers are integers. So this would be called a subset. Okay, and our subset is going to look like this. All of our whole numbers are a subset of our integers. Okay, so when we're looking at just all these different types of words and symbols, this is what they mean. This is the basis of them. We're going to go through them to hopefully understand them a little bit more in depth. So let's just go through a few examples here. If you need to take your time to write those down, please do so. Use the subset symbol to show the relationship between the set of natural numbers and the set of integers. So when we talked about natural numbers before, we've seen a chart like this where it said real numbers, and then we broke our real numbers up and we said, okay, in our real numbers we have irrational numbers and rational numbers. And then inside of our rational box, we said, okay, now we've got our integers, our whole numbers, and our counting numbers, or natural numbers. So comparing those, you can see that our Venn diagram is going to look like this. Here's our integers. So we'll just make it a Z. Here's our integers, and inside of our integers is our natural numbers. So if that is the case, then in order to use a subset symbol to show this, we're going to take our natural numbers and it is going to be a subset of our integers. Okay, so there's a few different ways to look at it, but if we have to use the subset symbol, there's our solution at the end there. So make sure that we know that there are different ways to show this and different ways to prove what you're trying to say, but if they're asking for a specific way, we got to give them the answer they're looking for. Sets A and B are shown below. Find A, and remember this symbol here means intersection. So A intersection of B. So we're going to take a look at A, and we're going to take a look at B, and we're going to find out where they intersect. So if I were to draw A and B, you can see there's going to be some form of intersection. In A, we have 1, 2, 3, 4, and in B, 2, 4, 6, 8. So the ones that they intersect with are 2 and 4. A over here, B over here. A has also 1 and 3. B has 6 and 8. So if we're going to use subset, okay, I shouldn't say subset, but if we're going to use intersection, the symbol, our A intersection B is going to be denoted by your braces, and then the 2 intersecting are 2 and 4. They also want us to find A union B. Okay, remember A union B is when we take and combine everything. So if we want to write this, okay, as elements of a set, we are going to include all of them. So we're going to just go in order. 1, 2, 3, 4, 6, 8. Keep in mind they don't continue on forever, so this is the end of your union B intersection. Okay, and I believe this is our last example. We're supposed to use a Venn diagram to illustrate the sets, and then we're supposed to find A intersection B. So we're going to continue on with the Venn diagram pictures. As you can see here, we're talking about the numbers 1, 2, 3, and here we're talking about natural numbers. Keep in mind 1, 2, and 3 are natural numbers. So our Venn diagram is going to be all inclusive. Okay? So our natural numbers are going to be right there. And we're going to have 1, 2, and 3 inside there. So there is a Venn diagram to show this picture. We can also show that A intersection B is 1, 2, 3. Okay, and A, we can also write it as a subset of. So A is a subset of B because it's all included in your natural numbers. For the second one, you're supposed to have A and B, and if you look at these two sets of elements, you're going to see they have nothing in common. So that means, in this case, for group A, 2, 4, and 6, and group B, 1, 3, and 5, A intersection B is an empty set. Okay, so there's an example of an empty set that you'll see there. So these are just a few examples that we're starting with. We're getting into the basics, so take your time, go through the steps, and in your next part of the problem, you can answer these practice set problems. I think I can squeeze them all on there. Okay, there are your practice set problems. They're also in your textbook, so make sure you complete those before your class hour that it's due. Thanks for tuning in to the Killorn Show, and come again.